Okay, so let's try out a couple example questions. Which research question below would require a one-tailed statistical test? Research question number 1. Do New York and Los Angeles have significantly different gas prices? Or research question number 2. Are New York gas prices significantly higher than Los Angeles gas prices? Which research question below would require a one-tailed test? Well, when you think about one-tailed test, hopefully you're thinking about directional research hypothesis, and which research question has or posits a particular direction. Research question number 2. It's asking if New York gas prices have higher prices than LA gas prices. Whereas research question number 1 is just asking if they're different. We're not asking or stating if one or the other city has higher or lower gas prices. So research question number 2 would require a one-tailed test. What about this example? Which hypothesis below would require a two-tailed test? Hypothesis number 1. Girls score more kickball points than boys. Or hypothesis number 2. There is a difference between boys and girls on the number of kickball points. Which hypothesis would require a two-tailed test? Well, two-tailed tests are what? Non-directional or directional hypotheses? Non-directional. So if non-directional, that means we're not stating which group has more or less of something. So hypothesis number 2 would require a two-tailed test. Because simply we're just saying that there is a difference between boys and girls. We're not saying if girls score more or boys score more. So two-tailed test would be hypothesis number 2. Okay, so I talked about one and two-tailed tests, and this is a visual of what I mean by a one and two-tailed test. Here's a nice normal distribution curve, and we'll learn all about the normal distribution curve and probabilities next week. But I just wanted to introduce the idea of one and two-tailed tests now as we start learning about hypotheses and how we write out hypotheses and their respective equations. So here's a video that just nicely introduces the idea of one and two-tailed tests.
In this tutorial, I'm going to discuss one-tail and two-tailed tests. We set this up by drawing a normal bell curve. And the bell curve represents 100% of all possible events. Right in the middle is the population mean, and we use the Greek letter mu. It looks kind of like a U. We'll call it mu. A sample mean can be anywhere within this green area. For sample mean, I use the notation x bar. The value of the sample mean can be above the population mean. It can also be below the population mean. And there's a probability that it will show up somewhere, the sample mean will be somewhere in this green area. With a one-tailed test, there's some probability that the sample mean will be in the green area. And I'm going to use a 95% probability. And that means there's a 5% chance the sample mean will show up in the red area. This red area is often known as alpha, the Greek letter alpha. Also to be used as the p-value. It's typically called the rejection region. The sample mean has to show up in the red area or in the green area because these two add up to 100%. In this example, I'm using a 95% confidence, and you could actually use any level you wanted to. I can also have a one-tailed test with the red area to the right of the population mean. There's a 95% chance a randomly selected mean will be in the green area, sample mean. There is a 5% chance it will appear in the red area, a randomly selected sample mean. But there is a 95% chance it will be in the green area. Again, the red area is often called alpha, referred to as alpha or the p-value, and we refer to it also as the rejection region. Now, when I create a two-tail test at a 95% level of confidence, I will take that red area and I'll put half of it to the right and half of it to the left. In other words, I take alpha divided by 2. So I take the 5% divided by 2, and I put 2.5% on the left side and 2.5% on the right side. You'll also see this alpha divided by 2 in other statistics formulas, and this is what it's referring to. There is 2.5% on the left and 2.5% on the right. 2.5% plus 95% plus 2.5% equals 100%. This means all observations and all events are covered. There is a 95% chance the sample mean will be in the green area, a randomly selected sample mean. There is a 2.5% chance the sample mean will be in the bottom tail, and there's a 2.5% chance the sample mean will be in the upper tail, right there. Now at a 95% level, there's critical values, and these are z-scores, negative 1.96 on the left and positive 1.96 on the right. When I return to a one-tail test, the critical value on the right is a positive 1.645, and the critical value to the left would be a negative 1.645. And this has just been an introduction to one- and two-tail tests, and there's more to come, more to learn about stats.
Okay, so as you heard in the video, you heard about rejection regions and alpha and p-value and critical values. Don't worry about that for this chapter. We'll learn all about those in upcoming weeks. But for the purposes of Chapter 7, I just want you to understand when do we use one- and two-tail tests, and just getting a nice idea of them visually in the context of what we saw in the video.